Okay, this is 1.8 coordinate geometry. I have given you the distance formula, and notice that you're subtracting your x's and subtracting your y's, and don't forget to take your square root. On midpoint formula, you're adding your x's and adding your y's. Okay, on number 1, it says find a point on the x-axis that is equidistant from the points 2, 2, and 3, negative 1. Okay, let's draw these points on an axis. So let's plot 3, negative 1 and 2, 2. And I want these to be equidistant. So it looks like it's going to be around that point right there. So here's 2, 2, and here's 3, negative 1. Okay, so in order to find this point right here on the x-axis, we know this point is going to be an x-intercept. And in order to be an x-intercept, that means it's going to be x, comma 0. So I'm going to go ahead and use my distance formula at the top. And I'm going to find the distance, because I need these to be the same. I'm going to find the distance between 2, 2 and my x-intercept, and 3, negative 1 and my x-intercept. X minus 2, so my x quantities squared, and add those to my y quantities, and subtracting those, square that, take the square root, and I need that to be equal to this distance. So I'm going to say x minus 3, so my x quantities squared, and I'm going to add that to my y quantities, which would be 0 minus a negative 1, so that's going to be a plus. And I'm going to take the square root of that. So over here, this is going to be x minus 2 squared, and this is going to be plus 4. And over here, this is going to be x minus 3 quantity squared, and this is going to be plus 1. Okay, you're going to have to double distribute these two things, and then I'm going to just start simplifying. So x is equal to 1. So that this, I didn't draw this very well at all. So really it should be going up here at 1, 0 is where it would enter. They would be equidistant. Okay, so let's look at x and y intercepts. So if you have an x-intercept, like we just looked at, your x-intercept is going to be an x comma 0, where your y value is 0. And a y-intercept is going to be a 0 comma y, where your x value is 0. So if you're looking at this problem that I just gave you, some of you might think it looks familiar. Some of you may not, and it's okay if you don't. This is actually an equation to an ellipse. So if you kind of remember that, that's cool. We'll get into this more later. But I want to go ahead and find my x and y intercept to this equation. So if I were to find my x-intercept of this first, that means that my y value is going to be 0. Okay, take your equation, and I'm going to find my x-intercept. So that means plug in a 0 for your y value. If you would like to, a 0 over 4, if you just think of that, 0 over anything is going to be 0, so that kind of cancels out. And then you just have an x squared over 9 equals 1. So really, this is the easiest way. Multiply by 9, and you're getting an x squared equals 9. Solve that. X is equal to positive and negative 3. So your x-intercepts are 3, 0 and negative 3, 0. Okay, now let's find your y-intercepts of the same problem. So that means you're going to have an x value of 0. So again, this kind of falls out really nice. So y squared over 4 equals 1. Multiply by 4. Y squared is equal to 4. Square root. Y is equal to positive and negative 2 because you're solving. So you have a y-intercept at 2 and negative 2. Whoops. All right, let's look at a circle. For those of you who don't remember, your center is at HK. You have a radius of R. So this is your circle formula. You need to know this. In the parentheses, you always have a minus sign. That's just the formula. That's what it's given. A lot of people forget that your radius is squared, so don't forget that. Okay, so it says find the equation of a circle with a radius of 3 and a center of 2, 5. This is just a fill-in problem here, so I'm going to say h or x minus, this is your h value, so x minus 2. This is a quantity squared, plus my y value, so this is y minus 5, quantity squared, and then I'm going to take my radius and square it, so this would be 9. And that's it, that's my answer. On number 4, when it says find the center and radius of this circle, this is kind of a hot mess. And so what I'm going to have to do here is to complete the square. We have done this before. I'll go over it as slowly as possible and rewind this if you need to. Watch it as many times as you need to. I'm going to take all my x values and group them together. So I have an x squared plus 2x. And I'm going to leave a blank here so I can group them. I'm going to do the same thing with my y's so that I have y squared minus 6y. Leave a blank for my y that I'm going to fill in. I'm going to move everything else that I didn't use on the other side. It looks like all I didn't use is a 7. I added a blank here. Oops, that's going to be negative 7. I added a blank here and a blank here, so I'm going to add 2 blanks on the right side so that I'm not changing my problem. Okay, now I'm going to take my middle term. Always take your middle term, and you're going to half it. And I always box it and square it. That goes here. So when you half box square that, that's a 1. Whatever you add to this side, you also add to this side. So that's a plus 1. Okay, I'm going to do the same thing here. I'm taking this term. So I'm taking a negative 6. I'm going to half it. I'm going to box it and square it. That goes here. So that's going to be a positive 9. I'm going to add it here and over here. So I'm adding it to both sides. Okay, now I just need to simplify this. Okay, so inside this, why you box this is the box is now going to go inside the parentheses. So I'm going to say my x and plus whatever was inside your box now goes down here. And this is a quantity squared. So plus down here, this is going to be my y's. And whatever was inside this box now goes down here. So this was a minus 3. Quantity squared equals this right side, whatever it simplifies to, is going to be my right side. So this is the equation of a circle. From here, I can get my center. My center is going to be this. Remember what I plugged in to get was a negative 1 and a positive 3. And my radius is going to be a root 3. Because I squared it to get this. And these are my answers. Okay, this last one is talking about symmetry with respect to the x-axis. If you have an ordered pair xy, then you're going to have an x comma negative y. And again, if it is respect to the y-axis, so if you start with an x comma y, then you would have a negative x, y. Okay, if it is symmetric to the origin, then your order pair would be negative x, negative y. All right, you may not always have ordered pairs, so we want to be able to test for symmetry if you have an equation. So how we can test with symmetry with an equation is we want to be able to replace things. So we are going to replace y with a negative y, which I did up here. That would be my x-axis. Replace a y with a negative y. So if I replace a y with a negative y, if your equation is unchanged, then graph is symmetric with the x-axis. If I replace, if I can, this is all, if you can do this. If I can replace the x with a negative x, then if my equation is unchanged, then the graph is symmetric with, this is all my same sentence, with the y-axis. Okay? If I can replace both, then it is symmetric with the origin. Okay, now let me show you what I mean. Here's my last problem. If I give you y equals x cubed minus 9x, replace the y with a negative y. So I'm going to go negative y, and that's the only thing I can replace on this. If I can replace it with the negative y and it be exactly the same, then it's symmetrical, and this is not. On B, can I take my equation and replace the x with a negative x? So can I replace this with negative x, cube it, and this with negative x, and it'd be the same as my original. So if I simplify this, negative 9 times negative x gives you a positive 9x. Whoops, that's still cubed. Is this the same as my original problem? No. So this is still not the same. So this is still not symmetrical. Still haven't found a symmetry. Okay, let's try replacing both. So I'm going to replace the y with a negative y, and I replace the x with a negative x. So is negative y equal to a negative x cubed? Okay, so the right side is good. Now I need to solve for y, so y is equal to a positive x cubed and minus x9. Haha! This one is the same as that. So that means, since this is the same, then we are symmetrical with the origin.